Good evening. I'm Mehmet Ansoy, Vice President of Denver Astronomical Society. We have the InReach presentation this evening, and our speaker is Hranac, who will be talking about meteorites, a collector's perspective. Ron is a member of Denver Astronomical Society, executive board member, and is a past president of the organization. In addition to enjoying visual observing with variety of telescopes that he has, he is an avid meteorite collector. He has lectured on meteorites at numerous venues and for several groups and organizations over the years, such as at the University of Denver's astronomy program, during DAS's public night events at DU's historic Chamberlain Observatory, at the Denver Museum of Nature and Science, for the Friends of the School of Mines Geology Museum, and at various elementary, middle, and high schools around the Denver metro area. Ron is a retired telecommunication engineer, but remains active in standards and specifications development committees. Ron, please proceed. The floor is yours.
Thank you, Mehmet, and I'll share an apology in advance with the group. As you can hear by listening to my voice, I'm congested, just getting over the latest respiratory stuff that's making the rounds. So if I suddenly go silent, you'll know I've muted myself to cough or something. Anyway, just wanted to let you know in advance. So thank you for joining the InReach tonight. I very much appreciate your time and attendance. The presentation I'm doing this evening is the same one that I do in our public night program at DU's historic Chamberlain Observatory. And the main difference between the way I'm doing it tonight and the way I do it in person, of course, is that at the in-person event, I pass real meteorites and meteorongs around the room, and along with some other bits and pieces that are related to meteorites. I can't do that here, unfortunately, since Zoom doesn't allow sharing real specimens in a virtual environment. So we'll have to put up with what's in the slides by themselves. I do encourage questions, and as Mehmet noted at the end of the presentation, we'll have plenty of time for questions and answers. So with that, let's get underway. Astronomy is, as Mehmet mentioned, is one of my hobbies, among many, or as my wife says, my hobby is having hobbies. And in particular, a subset of astronomy that has a real strong fascination for me is meteorites. I have enjoyed meteorites and been involved with them for more than 2 decades, and find the idea of being able to hold a rock from space that is older than any Earth rock is mind-boggling. But let's start with some of the terminology. And if you remember nothing else from tonight's presentation, I'd like you to remember the 3 words that I'm going to talk about here on this particular slide. And the first one is meteoroid. Think of this as the rock that's zipping through space at anywhere from 20,000 to 150,000-ish miles per hour. And it can be rocky, it can be metal or metallic, it can be a combination of those. Sometimes it's icy, so think of maybe a chunk of comet. Should the meteoroid go into an Earth-crossing orbit and enter the Earth's atmosphere, it can produce what we call a meteor. This is the second term to be familiar with. Now, the meteoroid itself is not the meteor. The meteoroid produces the meteor. The meteor is a streak of light that occurs in the atmosphere 50 to 75 miles or so above the surface of the Earth when that meteoroid enters the Earth's atmosphere at a very, very high velocity. Of course, we commonly call meteors falling stars or shooting stars, but they're not really stars at all. The meteors themselves are, as I noted, streaks of light, and they're surprisingly produced by typically very small meteoroids. The vast majority of meteors that we see in the night sky are produced by meteoroids that the meteors rather that we see are produced by meteoroids that are no bigger than a grain of sand to perhaps the size of a pea or thereabouts. Of course, there are bigger ones, and there are some that can produce visible meteors that can be seen in the daytime. I'll talk a little bit later on about the event in Chelyabinsk that happened back in 2013. that did produce meteorites on the ground, but it also produced a visible meteor in the daytime. And I was fortunate to have seen the visible meteor back in late 72, early 73. I forget which year now. There's been somebody took an 8mm film of it from the Grand Tetons on the west or the east side of the Grand Tetons, and you can see this object going from south to north. I was in northern Idaho at the time and saw it looking to the east. A friend and I were riding a motorcycle in my hometown and saw this thing appear at the southern horizon and go across the sky. And we stopped, turned off the motorcycle, didn't make a sound. I thought maybe it's an airplane on fire. Well, come to find out, it was a chunk of asteroid that had entered the Earth's atmosphere, was seen in 9 states and parts of Canada. And then the thing zipped out into space again. So that was a daytime meteor, which was also a fascinating object. Now, the third term to be familiar with is meteorite. Should the meteoroid survive the plunge through Earth's atmosphere, then it's known as a meteorite. Now, a little bit of technical trivia related to the term meteor. The word itself has its origins going back to the 1500s or thereabouts. And at that time, it referred to pretty much any atmospheric phenomenon that included hail, rainbows, lightning, rain, wind, and then, of course, the familiar shooting or falling star. All those were meteors. And if you think about it for a moment, we think of a meteor from the perspective of being an atmospheric phenomenon, that can lead us to apply some names to the sciences, and I say sciences, related to the term meteor. And of course, one of the most common ones that I would suspect most of you are familiar with is the name given to the person on TV who does the weather. That person is a meteorologist, a person who studies atmospheric phenomena, specifically weather. In the case of the science of meteoritics, and yes, there is a branch of science known as meteoritics, the scientists who do that, who study meteorites, are called meteoriticists. But where do most meteorites come from? Well, the vast majority come from the asteroid belt, which orbits the sun in between the orbits of Mars and Jupiter. Now you can see in this graphic, there are some Trojan and Greek asteroids. Now this one has both of them listed as Trojans, but one is, as I understand, is called the Greek asteroids. The other is called the Trojan asteroids. And those are captured in Lagrange points in Jupiter's orbit. But the bulk of the asteroid belt is found in between Mars and Jupiter. And that's where most meteorites come from. Now, this graphic is a little bit misleading because it looks like, gee, all the asteroids in the solar system, with the exception of, we'll just call them the Trojans, in orbit near Jupiter, that's all there is. Well, no, there are asteroids all over the solar system, including many that go into Earth-crossing orbits. And occasionally, some in the asteroid belt will get knocked out of their orbit because of collisional processes or because of the gravitational tugs by Jupiter, and then they can eventually find their way into an Earth-crossing orbit. Not all of them do, of course, but some of them do. And then should those meteoroids enter the Earth's atmosphere, we see them as meteors, and if they make it to the ground, we may well see them as meteorites. So most come from the asteroid belt. Now, if we think about the asteroid belt, what the heck is it? Well, I like to use an analogy that it can be thought of as construction pieces and parts left over from the formation of the solar system. Not unlike walking by a lot where a house is being built, you might see scraps of lumber and pieces of wire and pipe and stuff laying on the ground that are the scraps left over from the construction of the house. The asteroid belt is leftovers from the construction of the solar system. And of course, that makes meteorites of high interest to the meteoriticists who study them, because they can tell a lot of information about the early formation of our solar system. There are a couple exceptions to the source of meteorites, being the asteroid belt, and they are lunar meteorites and Martian meteorites. And of course, you think about that for a minute and wonder, wait a minute, how on earth would a meteorite come from the moon or Mars? We'll talk about that a little bit later on. Now, meteoriticists, like many other scientists, like to classify the things that they study. Scientists love to classify flowers and insects and rocks and minerals and so on. And meteoriticists are no different. They classify meteorites. I'm not going to talk about classification because that's a presentation by itself, and it would ensure that you have no trouble getting to sleep tonight. That is not what I would call an exciting topic, but it can be interesting. Instead, what I want to do is emphasize that we can group meteorites into three main categories. The first is stony meteorites, which is pretty much what the name suggests. These are rocky. They're made mostly of silicates. They've got some iron nickel content that can range from a few percent to 20 or 30%, but it tends to be peppered throughout the stony material, the silicate material. And if you slice one open and look at it, it almost looks like somebody took a salt shaker full of glitter and sprinkled glitter over the surface. And what that is the iron nickel material that's interspersed with the silicates. Stony meteorites typically come from undifferentiated asteroids. An undifferentiated asteroid is one that is small enough that when it formed, it didn't have enough gravity to separate the heavy, denser stuff into the center and the lighter stuff to the mantle and crust. So most stony meteorites come from undifferentiated asteroids. There are some that come from differentiated asteroids, and primarily the crust from those asteroids. The second type is an iron meteorite, or some people call it an iron nickel meteorite. These come from the core of a differentiated asteroid. That is, an asteroid that was large enough when it formed and was still molten that all the heavy stuff sank to the center. So that would be the iron and nickel and so on. And then the lighter stuff floated up to form the mantle and the crust. The iron meteorites are also what most people tend to think of when they think of meteorites, because this is often what you'll find on display in museums. And you'll see examples of the others, of course. But many times the iron meteorites have just these beautiful, almost sculpted looking shape that are called regmaglets, or the nickname is thumbprints. Those form as the meteoroid is plunging through the atmosphere and material is ablated from the meteoroid, and it produces those beautiful thumbprints. The third kind is a stony iron meteorite, which is a bit of a mix of the first two. These are believed to come from the core mantle boundary of a differentiated asteroid. Now you look at this picture of Jeff Notkin and Steve Arnold on the right from the old Science Channel program, The Meteorite Men. They're holding a stony iron meteorite, but you look at that and you really can't tell much from that. I mean, let alone that it's a meteorite, but they dug this one up someplace in Kansas. But it is a stony iron meteorite. I've got a picture of the inside of one of these coming up here. So that's a nice segue to what is inside of a meteorite. Now, if we think about the Campo del Cielo iron meteorite, which is one of the specimens that I usually pass around the room in a person-to-person or an in-person presentation, this one is, as its name suggests, an iron meteorite, but it's about 92.5% iron, about 6.5% nickel, roughly 0.5% cobalt, and it's got a little bit of phosphorus and then some traces in the parts per million range of gallium, germanium, and iridium. Now, I like to stop and ask the question here, as you look at this list of ingredients for Campo del Cielo, which, by the way, is Spanish for field of the sky, what's the significance of iridium in a meteorite? And I'll explain that by reminding you that some 66 million years ago, an asteroid impact on the Yucatan Peninsula called the Chelyabinsk Event did a number on the dinosaurs. Now, some scientists think that other things like volcanism and so on may have contributed to the beginning of the demise of the dinosaurs, but it was this impact that I think sealed their fate. And the evidence for that is in the rock layers called the KT boundary. Now, some call it the KPG boundary. I still call it the older name, the Cretaceous Tertiary boundary. But at that boundary in the rock layers, there's a roughly 1/2 inch to 1 inch thick layer of material that has a relatively high concentration of iridium in it. It's in the order of parts per million. And you think, well, that doesn't sound like that much. But when you understand that iridium in the Earth's crust is extremely rare and in the parts per billion range of concentration, you can see that finding this thin layer at the KT boundary with this high level of iridium said, ooh, impact, because comets and meteorites and asteroids have iridium in them. So that was the evidence that was the smoking gun, if you will, for confirming that, okay, it was an impact event 66 million years ago that contributed to the demise of those dinosaurs. So here's some examples of what some of these things look like on the inside. As you look at this slice of stony meteorite, it looks kind of boring. It's, as I noted earlier, mostly silicates, so mostly rock, but you'll see these little, looks like shiny metal flakes in here that are scattered around like somebody sprinkled them on there with a salt shaker. You'll see some round objects, those are called chondrules, and they give this type of meteorite its general name, which is ordinary chondrite. The chondrules are little spheres that are believed to have formed when the solar system formed and material started to condense into little droplets. They solidified and then accreted into larger bodies. So the chondrules are of particular interest for the scientists who like to study the early origin of the solar system. Iron meteorites are kind of fun because most of them, not all of them, but the vast majority of them, when sliced, polished, and then etched with acid, produce this crystalline crosshatch structure that is the crystalline nickel iron material in there. This is called a Wittgenstein pattern, named after one of the people who discovered it. The Wittgenstein pattern can be thought of as fingerprints of sorts because different asteroids from different parent bodies have different Wittgenstein patterns. So scientists can use these to help identify the type or classification of the iron meteorite. And then the third kind is a peek inside of a stony iron meteorite, in particular a palisite. And here you can see the iron nickel matrix, much like you see in the iron meteorite over to the left. And there are some signs of the Wittgenstein pattern here, but you also notice these kind of yellowish crystals in here. These are olivine crystals. Those, if any of you have a birthday in the month of August, you may recall that your birthstone is peridot or peridot. That's the gemstone variety of olivine. So if you or a friend or relative have a birthday in August, here's your birthstone inside of a stony iron meteorite. All right, so I've talked about the three main categories of meteorites and three terms to not forget. There could be a test, you don't know. Meteor, meteoroid, and meteorite, and a few other things. There must be some evidence of impacts, right? After all, these things do leave evidence in the form of impacts. In particular, you can see this if you have looked at the moon through a telescope. Not only does the moon have a lot of impact craters, so does Mercury. Mars has a few. Mars' two moons, Phobos and Deimos, have impact craters. Many of the moons of the giant gas planets and ice planets have impact craters. And we know, of course, that Pluto and its moon Charon have impact craters. So if we've got all these impact craters all over the solar system, that's, I think, a pretty strong suggestion that impacts happened in the past. Yet when we look at our own Earth, we certainly don't see as many impact craters as we see on the moon, which is right next door. So hasn't Earth been whacked by space debris? And where are all the craters? Well, the answer is yes, there is evidence of meteorite impacts on Earth, but what and where? And I'll show you some examples here in a moment of different types of evidence of impact, but there are craters. And you say, well, all right, what happened to them? The reason we don't see more craters on Earth, especially in numbers like we see on the moon, is because we have plate tectonics going on. We have volcanoes that erupt and cover things up. Erosion and weathering have fortunately or unfortunately, destroyed or hidden most of the impact craters on the Earth. Arguably, the most famous impact crater is what's called Meteor Crater in Arizona. This is located just off of Interstate 40, about 45 miles east of Flagstaff or close to Winslow, Arizona. The crater's out in the desert. It's about 3/4 of a mile wide and 600-ish feet deep. Scientists know of a bit more than 190 confirmed impact craters on Earth. if any of you have been to Meteor Crater in Arizona, which I consider misnamed, it should have been Meteorite Crater, but that said, this is a pretty cool thing to see out in the middle of nowhere. It's just this big hole in the desert. There's a neat gift shop and museum there. It's been several years since I've been there, but they charge by the person, as I recall. It's definitely worth going to see if you're in the area. Just if nothing else to say, hey, I've seen Meteor Crater. It's been in a lot of movies and documentaries and so on, but there's nothing quite like standing on the edge and peering into it to see this thing formed by an impact about 50,000 years ago. Other examples of evidence of impacts include impactites. This is typically glassy-like material of terrestrial origin, which means think of it as rock and dirt and sand and so on that was transformed or changed by an impact. The photograph here shows what's called Libyan desert glass. This is found in the Sahara Desert near the border between Egypt and Libya. And it was formed in the past by what's believed to be an airburst. Scientists have not found a crater in the desert, even using research tools to look under the sand. So the thinking is that it was probably an airburst, either a chunk of asteroid or comet that exploded in the atmosphere above the desert, and the heat of the explosion or airburst melted the sand to form glass. This has been known for a long time. The ancient Egyptians used Libyan desert glass to make jewelry. In fact, jewelry in the tomb of King Tut contains Libyan desert glass. So this stuff's been known for a long time. Libyan desert glass is one of several types of impact glass. It's still available on the collector market. A lot of people like to make jewelry out of it. Some people like to just collect it. Another type of impact glass is moldavite, which comes from the Czech Republic. It's a really pretty green color. That was formed by a meteorite impact in Germany, and the impact formed the glass which fell into parts of the modern day Czech Republic. There are also tektites that are found in Southeast Asia primarily, but the tektites from some kind of an impact around 700-ish million years ago in that part of the world. And scientists have not yet identified or confirmed where the impact occurred exactly. But the tektites, which can take the shape of teardrops or dog bones or round balls or even little flanged buttons, have been found over roughly 10% of the Earth's surface. And they're found as far away as Australia, found all over Vietnam, Cambodia, southeastern China, Philippines, and so on. And they're all from that same impact event. But those are all examples of impactites. Shatter cones are another type of evidence of impact. I like to call these fossilized shock waves. And you look at the photograph here, you can see almost some cone-shaped grains in the rock. The shatter cones can range in size from less than an inch tall to 10 or 12 feet. There's a geologist rock pick in the photo here, and you can get an idea of the scale of these. This expanding cone, if you will, always points up to the impact. These typically form beneath the crater of an impact. There's a good source of shatter cone near Santa Fe, New Mexico. I've got a piece of it that I like to pass around the room when I'm doing an in-person presentation. It's not on I-25, but it's on one of the state or county roads near Santa Fe, and it's found in a road cut. The crater, of course, is long gone. It has eroded away, but the shatter cone remains, and that's good evidence of an impact in the past, a long, long time ago. And then there's microscopic evidence of impacts. You may have heard of shocked quartz. Shocked quartz is commonly produced in the vicinity of a nuclear explosion, but it's also produced at the site of a meteorite impact. And there are a couple different types of stishovite and coesite, but this is evidence of a meteorite impact. And microtektites, which are basically melted beads of glass, are also evidence of a meteorite impact. Of course, no discussion about meteorites would be complete without also mentioning meteor wrongs. Meteor wrong is not a scientific. This is a nickname given to earth rocks and minerals and some man-made material and objects that are commonly mistaken for meteorites. In Colorado, we've got some real common ones that people will often find in the mountains. Hematite and magnetite are two real common examples of meteor wrongs. And then non-rocks such as smelting slag. And of course, there's a smelting operation at the steel mills down in Pueblo. And of course, this stuff goes on all over the world. But interestingly, the smelting slag is often used or mixed in with the gravel in the bedding under railroad tracks. It's mixed in with the gravel used in gravel roads. Sometimes it's used as fill in landscaping and so on. But I get a chuckle when I hear of somebody walking down a railroad track and I found this melted looking rock. It must be a meteorite. And they walk a few more feet. Oh, there's another meteorite and another one and another one. It just happened to be lined up in a row going down the railroad tracks. And the answer is no. Sorry, that's man-made slag. That is not a meteorite. So here's a couple examples of some of the meteor wrongs from my collection. I'd like to set it up on display in the in-person presentation. And I have one meteorite hidden amongst the roughly 24 meteor wrong specimens. And then I like to encourage people to figure out which one of the specimens is a meteorite. And it's much more difficult than you might think. Excuse me. Here's a good example of a type of rock that many people commonly mistake for meteorite. What they do is they mistake vesicles or bubbles and holes in lava rock for the thumbprints or regmaglyphs that are seen in many meteorites. But when you put the two side by side, you can see right away, okay, they're not the same. Obsidian, of course, most of us know as volcanic glass. And you wouldn't think of this obsidian, you wouldn't think a piece of obsidian would be mistaken for a meteorite. But I found this one in a rock shop. I was on a business trip years ago. And yes, I used to go to rock shops on business trips. And the rock shop had this basket of obsidian. So I walked by it and saw this piece up on the top. I thought, ooh, that looks kind of like a worn, weathered, stony meteorite. And of course, flip it over and see right away there's a conchoidal fracture, which meteorites don't have. And it had been cut and polished. So it's very obviously not a meteorite. But from this side of it, it looks kind of like one. Magnetite, really, really common meteor. It's heavy for its size. It's dark colored, sticks to a magnet. But this is terrestrial iron ore. This is not a meteorite. Slag. Now, this is not the only example of slag. Slag comes in all kinds of textures and shapes and colors. Some is attracted to a magnet, some's not. But man-made slag is not a meteorite. Neither is botryoidal hematite. This is also a type of iron ore. The botryoidal name is given to this bubbly texture on the outer surface. And I remember picking this one up in a rock shop and thinking, all right, somebody's going to look at that and say, oh, that must have melted that way coming through the Earth's atmosphere. Well, no, that one formed underground. And then Moki marbles. These are iron oxide concretions that are found in the deserts of the southwestern United States. They form in the sandstone in southwestern Colorado, Utah, Nevada, parts of California, and so on. There are a couple things here. First of all, this one is nice and round. Meteorites are typically not round. So if you see a nice round specimen, unless somebody has turned a meteorite into a round ball, which some do, they'll cut it and machine it and then polish it and whatnot and get a nice ball that looks like a billiard ball or something. I'm not personally a fan of those. There are people who collect them, but round meteorites typically don't occur like this naturally. So when you see something like this, you can think, all right, that's a meteor wrong. Let's talk a little about the Chelyabinsk event that happened back in 2013. It was Valentine's Day here in Colorado, a little after 8 p.m. our time, which meant it was the next day in Russia, Friday morning. So there were still people on the way to work. But at that time, the 65-foot wide, 10,000-ton meteoroid or chunk of asteroid entered the Earth's atmosphere at about 40,000 miles an hour. The meteoroid exploded 15 to 20 miles or so above the surface of the Earth, and it released a shock wave when it exploded. The energy released in that shock wave was on the order of the equivalent of 30 Hiroshima atomic bombs. Interestingly, when people saw the flash, they went to the window, and about 90 seconds or so after the flash, the shock wave arrived, and it blew windows out of thousands of buildings. About 1,500 people were hospitalized because of injuries from flying glass. You can see in the pictures here, broken windows on a building. There was, I think, a zinc factory that had it was an older building. The shock wave actually knocked the walls over. And then here you can see the aftermath, people sweeping up broken glass. The explosion vaporized most of that 10,000-ton meteoroid, but what survived scattered over a strewn field, as we call it. It's probably several square miles in size. You probably have seen the picture on the lower right on the news or on the internet back when this event happened. That's where the biggest piece of it was eventually recovered. The meteorite is named after the city of Chelyabinsk. That's what it was closest to. That's a city of about 1 million in big industrial city. So it's officially been classified as a stony meteorite, in particular an LL5 chondrite. The LL5 designation has to do with the relatively low iron content, and then the number 5 is related to some petrology things that the scientists who classify these things like to follow, but we won't go there, as I promised earlier. As you look in the right over here, you can see that the fragments that were retrieved range from pea size over here on the right of this upper right photo to grapefruit size or thereabouts. It can be seen in this person's hand. These are really cool meteorites because the outside has this charcoal black fusion crust that formed when the meteoroid was passing through the atmosphere. For a few brief seconds, the outer couple millimeters or so melted, forming this fusion crust. The inside is pretty much pristine, the way it was in space. So it's this almost grayish looking with just a little bit of iron in it, flakes, and the chondrules in it are extremely tiny. And then the photo of the lake here is where the big chunk landed. It took about 6 months for them to recover the meteorite that punched the hole in the ice, but they finally did get it out. Here's a photograph of it on the lower left. Weighed about 1,400 pounds, broke the scale when they weighed it, but that was the confirmed weight. So you can see it right there, roughly 1 meter in diameter or so. There it is in a museum in Russia, and you can see that after it dried out, it's really not real nice looking anymore. Recall that the other specimens had that nice black fusion crust and that pristine gray interior. And unfortunately, just a few months exposure to the rock and the mud really degraded the condition of the main mass of this meteorite. To date, more than 2,000 pounds of Chelyabinsk meteorite have been recovered. It's widely available on the collector market. It's relatively affordable. So it is out there if that's something that you're interested in. Of course, I'd like to ask people when I reach this part in the presentation, has this material inspired an interest in collecting meteorites? Do you expect that you'd get rolled eyes from your spouse if you decided to take up this hobby? And of course, I get a chuckle out of that. But then get on into the fact that if you want to collect meteorites, the first step is to learn a little bit about them. And you have been sitting through this presentation this evening learning, at least from a real high level perspective, some of the basics of meteorites. I would refer you to the International Meteorite Collectors Association website as one resource. Another is the Meteoritical Society. This is where papers are published, and this is where the scientists and the meteoriticists hang out. There really is a Meteoritical Society, and it's a professional organization, but they've got a lot of really good information on their website. And then books. There are all kinds of books out there. There are 2 in here I want to highlight. Now, these are all good. I've got copies of all these in my library. The one on the far right is called "What's So Mysterious About Meteorites." That's a great book for kids. It's also a great book for adults if you just want to get a really high-level introduction that does not get technical in the subject of meteorites. The other one that does a deep dive is called "Rocks from Space." Be sure to get the second edition. That's written by O. Richard Norton. Richard and his wife, Dorothy, co-authored the "What's So Mysterious About Meteorites." He passed away before it was published, so she finished it. She's just such a wonderful, wonderful person. But this is a great book too. But "Rocks from Space," second edition. If you have an interest in meteorites, get this one. This one will answer a lot of questions that you may have, and may answer some questions you didn't know you had. All right, well then that leads to another question. What kind of collection? Maybe you would be fine with a simple three-piece collection of a stony, an iron, and a stony iron. Put them up on the mantle above the fireplace and call it good. That's fine. Maybe you want to go for a prepackaged collection. It's been some time since I checked Jeff Notkin's website. He sells this little prepackaged set. Last time I checked, it was about $225. I'm not sure if it's still that or if it's gone up, but it's a nice little set because it's got several specimens plus a couple of fragments in it. Whoops. So I didn't want to cough in your ear there. If you get more serious into collecting meteorites, well, then you can get into different subcategories. Some people try to collect examples of all the different classifications that exist, although that can be difficult because some of those classifications are extremely rare, and there may only be one or two of available anywhere, and might be better off called unobtainium. Some people like to call or collect meteorites from different locations. For example, Colorado has about 90 confirmed meteorites, and roughly half of them are collectible. That is, they're available on the collector market. The others are in museums. There may only be one or two pieces, so they're in the Museum of Nature and Science or the Smithsonian or something, and there's not any more of that type. But there may be 40 to 45 Colorado meteorites that are on the collector market, and the prices are all over the place from affordable to not so affordable. Some people like to collect falls versus finds. A fall is a meteorite that was witnessed. So the Chelyabinsk event in Russia would be, or a meteorite from that would be considered a fall. That tends to jack the price up a bit compared to a find, which is a meteorite that was just randomly found someplace. Another type that people like to collect is hammerstones. That's a nickname given to meteorites that hit things like cars, houses, office buildings, barns, boats, mailboxes. Everything I just mentioned, I'll throw in one more, doghouse, has been hit by a meteorite. And you may have heard mailbox in there. Think, wait a minute, a mailbox got hit by a meteorite? That would be the Claxton meteorite from Georgia. The meteorite whacked a mailbox. The mailbox sold for $82,000. That's a yikes. Some like to collect thin sections. Some like to collect impactites, which I talked about earlier. And of course, some like to collect Meteorongs. These are all fun things to collect, but if you start collecting these things, that tends to mean you're a bit more serious about the hobby. All right, where do you get them? Well, you can buy them at some rock shops, although my experience suggests that rock shops tend to be a bit pricey for meteorites. Of course, if you see a nice one in there and it's just one of those that you got to have, maybe you do a little bit of negotiating with the owner and see if you can get a better deal on it. But there are other places where you can usually get better deals. Online auction sites are one example, but if you don't know the seller, I would urge you to stick, at least initially, with members of the International Meteorite Collectors Association. There are some unscrupulous sellers online, as many of you may know. Some of them try to sell regular, ordinary, low-cost meteorites as rare meteorites, or particularly rare types, or they may be selling earth rocks and man-made slag as meteorites, and they're just total scammers. So just be careful. There are online dealers who are not members of the IMCA, but if you don't know them personally, I would just be careful until you get to know who they are. There are several really good online dealers, and I've listed 4 of them here. This is not intended to be an endorsement of these. I thought at one time, well, I'll put down a list of the websites where everybody I bought from. I didn't fill up a whole slide in really, really small print. But these 4, I will note, I've dealt with over the years, and they're all very reputable. Aerolite Meteorites is run by Jeff Notkin. He's one half of the Meteorite Men TV show. Impactica is run by Ann Black here in Denver. She actually has an asteroid named after her, named for her. But she's one of the top meteorite dealers in the world. Very, very knowledgeable. She's right here in Denver. Mile High Meteorites is run by Matt Morgan. He's here in Denver. I think he was just recently promoted to the USGS state geologist. And he's been selling meteorites online for a long time. A really, really nice guy. And then the meteorite market, that's run by Eric Twelker. He's a retired geologist from Alaska. He's retired into the Seattle area now, but he's been selling online going back to the 90s. And there are quite a few others I didn't mention here, but I just listed these as a few, just for examples. Probably my favorite place to look for meteorites is not out in the boondocks, because the odds of finding meteorites out kind of randomly are almost zero. They're really hard. For me, it's easier to go to a rock and mineral show. There's one this weekend at the Jefferson County Fairgrounds. I'm not going because I'm still getting over whatever the respiratory thing is that I've got. I don't want to spread that around out there. But there's a small one out there, and there are usually a couple dealers out there that sell meteorites. So the show will be going on tomorrow. If that's something of interest, I mean, just walking around, it's a small show. It takes an hour, a couple hours to walk around. It's fun just to look at rocks and minerals, but if you're interested in meteorites, Mike Jensen usually has some for sale, and there's usually 1 or 2 other dealers that might have some on their table. But the big shows are the best places to get them. What we call the spring show here in the Denver area takes place, next year in April, early April of 2023 at the Crown Plaza out at Chambers and I-70. That's a fun one. That's all in one place. Then the big one is the fall show, as we call it. Late summer might be more accurate, but that's typically in September. So that'll be mid-September of 2023, and that's in multiple venues around the metro area. Not only the Crown Plaza, but the National Western Complex, the Coliseum, the Convention Center downtown, and several other venues. So it's a fun one to go to, and if nothing else, just to look around and see rocks and minerals. But the show brings in meteorite dealers from all over the world, and the Crown Plaza and the Coliseum, and to some extent the National Western Complex, or the Coliseum and the Crown Plaza. Those 2 places typically are where most of the meteorite dealers are. So anyway, those are great places to get meteorites if you're interested. All right, let's move into some common questions, and then I'll open it up to questions from you. How big are meteorites? Well, that's one of those things it depends. They range from less than a pea in size to the size of a car. The largest known meteorite is the Hoba meteorite in Namibia. That's shown in the photograph over here to the right. It weighs about 60 tons and is roughly 9 feet by 9 feet by 3 feet in size. And of course, at this time, I pop up with this question. This is after I've passed meteorite specimens around the room. And I asked the question, are meteorites radioactive? And the answer is no more than your hand. You can thank Hollywood for this myth. How old are meteorites? I mentioned earlier that they're older than any Earth rocks. And of course, the reason is that there are no original Earth rocks left from the formation of the Earth, because the rocks on Earth have been recycled oftentimes, many times, by plate tectonics and volcanism and other processes. So most meteorites are between 4.5 and 4.6 billion years old. Those are the ones from the asteroid belt. Martian and lunar meteorites are a bit younger than that. We'll get to those in just a moment. This is a fun question. Has anybody ever been hit by a meteorite? The answer is yes. Back in 1954, Ann Hodges was taking a nap in her house in Sylacauga, Alabama, when a meteorite crashed through the ceiling of the house, bounced off of a radio, and hit her in the side. The photograph on the left shows the really nasty bruise she got from this. She had her picture in Life magazine back then. There's the hole in the ceiling of the living room, and there she is holding the meteorite that hit her. That meteorite is now on display in the Natural History Museum in the state capitol. There was another piece of that meteorite that likely broke apart when it was plunging through the atmosphere. It was found about a half mile down the road in the ditch. It was confirmed to be part of the original meteorite. I mean, it didn't break off inside the house. It actually broke off in the atmosphere at some height. And occasionally, tiny, tiny fragments of that one do show up on the collector market, but it tends to be rather pricey. And do meteorites contain any mysterious or unknown ingredients? And if you're a fan of the X-Men, and in particular Wolverine, I have to say I apologize to you. You may know that his bones were strengthened by something called adamantium, which in the movie came from a meteorite. Well, I'm sorry, there is no adamantium. It's not made from meteorites. There's nothing mysterious. Stony meteorites, as I discussed earlier, are made mostly of common silicates, so rock. Iron meteorites, mostly iron and nickel. Now, it is known, and this is true, that meteorites can contain some trace elements. For example, iridium, in some cases, may also contain some previously unknown or rare minerals. An example of the latter is wasonite, which is a titanium sulfide discovered a bit more than a decade ago. It's named after John Wasson, now the late John Wasson, one of the most well-known meteoriticists in the history of meteoritics. This stuff is really unstable in the presence of oxygen and moisture. So once it reaches the Earth's atmosphere, it does not last very long. It tends to break down very quickly. But in the vacuum of space, it does just fine for millions and millions of years. But microscopic amounts of this have been found in some freshly fallen meteorites. Okay, let's get back to the topic of lunar and Martian meteorites. I mentioned that there are two examples that scientists have confirmed are not from the asteroid belt. And the question, of course, is, all right, well, how do scientists know that they came from the moon and Mars? And it might be better to ask another question first, and that is, how on earth would a chunk of the moon or a chunk of Mars find its way to Earth as a meteorite? And the answer to that is asteroid impact. So think of an asteroid whacking the moon with enough energy to blast away crustal material that exceeds the escape velocity. And most of those pieces go who knows where, but some go into an Earth crossing orbit and wind up as meteorites on the Earth. Scientists know that they're from the moon because we have moon rocks that the Apollo astronauts brought back. And it's possible to do a comparison of the chemistry, if you will, of these lunar meteorites or suspected lunar meteorites with the specimens that came from the moon. So we know that, in fact, they did come from the moon. Now, in the case of Martian meteorites, it's a little bit more complicated. But back in the early 80s, there was a meteorite discovered in Antarctica, and it was a kind of an oddball meteorite. Just, all right, this is a little different, but scientists discovered embedded in the rock microscopic gas bubbles. And when they did isotopic analysis of the gas in those little microscopic bubbles, they found it was Martian atmosphere. And of course, we have not brought any specimens back from Mars like we have the moon, but we sent probes to Mars in the 70s and measured the atmosphere there. So we know what the Martian, and we have done more of that since. We know what the constitution of the Martian atmosphere is. And when you find microscopic bubbles of Martian atmosphere embedded in a meteorite, you know that it came from the planet Mars. There's also some isotopic ratios that get involved in this. For the chemists in the audience, there's some information about some of the isotopes that the scientists like to look at in the Martian rocks. And this is a fun question here. How many meteorites hit the Earth every year? It might surprise you. It's about an estimated 60,000 tons, which works out to something in the range of 18,000 to 84,000 meteorites. But unfortunately, or fortunately, I guess unfortunately for the meteorites, about 70% of the Earth's surface is covered with water, so most of those meteorites wind up in the deep. And everybody wants to know this. How much do meteorites cost, or are they worth? And that's another, it depends. They're priced by the gram. The lowest cost you can expect to get a meteorite for is somewhere probably in the range of 10 cents to 20 cents per gram. And that would be for probably a larger piece, because as the price goes up, oftentimes the price per gram goes down. But that would be for an unclassified Northwest African fragment. And then it can go as high as several $1,000s per gram. There's some that are in the $5,000 to $10,000 plus per gram range, which are just, it's insane, but they're extremely rare. And that's what they sell for. That said, you can get decent meteorites for, good quality meteorites for somewhere in the $1 to $10 per gram range. And with that, I'll open it up for questions.
Thank you, Ron. Can you stop sharing?
Sure.
Good. Thank you. Thank you. Let me start with my question. Actually, you posed quite a few questions yourself and answered them. My question is going to be actually non-technical on the legal aspect of owning meteorites. If you find something, are you entitled to own it? What is the legal aspect of ownership of meteorites?
If a meteorite is found on private property, it belongs to the owner of the property. So if it lands on your property in your backyard, it's yours. If you're renting the house, it belongs to the landlord. In the case of Ann Hodges and the meteorite that struck her in 1954, she was a renter, and she got into quite a dispute with the owner of the house, who said, well, I own the house, so I own the meteorite. And she said, well, I'm the one that was hit by it. I should own it. And they went back and forth and eventually came to a resolution, and she and her husband got to keep it. And then they tried to sell it. And unfortunately, in those days, I don't think there was as much interest in meteorites among private collectors, because if somebody got hit by a meteorite, it was documented like that today, there would be people banging at the door with their wallets out saying, all right, I'll give you X amount of dollars for it. If you find meteorites on public lands, for example, BLM, Bureau of Land Management has specific rules that allows, and I'm going by memory here, I think up to 10 pounds of meteorites per year, if I remember right. And then beyond that amount, then the meteorites have to be turned over to the Smithsonian Institution. And I think the same is true probably for national forests and stuff, but for small quantities, you can keep them.
So if you are camping in a state park or federal or national park.
Well, state park, it's probably going to belong to the state. The regulation that I mentioned about the BLM, as far as I know, applies just to the BLM lands. But a state park, that would probably belong to the state, or the if it was a county park or a city park or something, it would belongs to the property owner.
Okay. Any other questions?
Mehmet?
Yes.
Okay, it's interesting. Yeah, I found this very interesting, but this morning I was looking at an article on Smithsonian Magazine, and they have a story about a very unusual meteorite called the Winchcombe meteorite that lit up the skies in the UK before crashing in a driveway in Gloucestershire, England. And they studied it, and they're claiming it to be a carbon-rich rock called a carbonaceous chondrite.
Yep.
Okay. Now, what's interesting about it is they further claim from studying the meteorite that it could have transported water from, H2O. It could have transported water to the Earth. What I found a little bit strange is they further made a statement that it could have been one of the sources of water on planet Earth. Well, I found that claim to be a little bit hard to believe. You'd need a shitload of these this type of meteorite. But Ron, have you ever heard of a carbonaceous chondrite?
Oh, yes, I have several in my collection.
You
They tend to be priced a bit higher. Carbonaceous chondrites are interesting material. They're a bit rare because they're friable. They often don't survive the plunge through the Earth's atmosphere. They contain organic compounds, not life, but all the base organic compounds I think have been identified in carbonaceous chondrites that have been found in Australia and Mexico and elsewhere. Yes, some of these do contain water, and the thinking is that the water isotopes that they found in some of these tend to be a closer match to the water we have on the Earth than the water, what do they call that? The deuterium in comets, because the original thinking was the comets were likely the major source of water on the Earth, and now they're thinking maybe not. Maybe it was asteroids and a lot of asteroids. So you think
it would take a lot of asteroids.
Well, the late heavy bombardment 3.5 billion years ago resulted in some serious impact events, and I suspect they were all there were probably a combination of comets and asteroids that contributed at least some of the water to Earth. But yes, carbonaceous chondrites are interesting meteorites.
He's actually asked my question.
Okay, Mike Gardner.
Yeah, actually, the last question was one of the questions I had. The other question, or one of the other questions I've got, is we were talking about what, why we don't find very many meteor craters here on the Earth. I'm just wondering, what was the effect of the moon in protecting Earth, particularly, for instance, against the big bombardment you just mentioned, and then any other time? I heard that it was some sort of a shield.
It might have had a minor impact, but the moon is small enough that it probably didn't have a significant impact. If you look at how much the moon got hit, you'd think, well, wait a minute, wouldn't the Earth have protected the moon? Because the Earth had a bigger gravitational tug and an impact, and well, no. The Earth got whacked got whacked probably more than the moon did, if you just think of pure quantity, because we're a bigger target.
Yeah.
Okay, Mark Chrisman.
I've been for many years. I know that the odds are extremely remote, but spending a lot of time kicking around in the desert and up in the mountains because I want to find my own rather than just buy one. But I had never considered the legal aspect of it. My plan was just when I found it, it's my property and I wouldn't say anything. I've got a couple of geologists that are knowledgeable on the subject that I always take when I find them. I take them over there, ask them what I've got, and everything has been a Meteor Wrong every single time. And some of them looked like they were good candidates.
Oh yeah.
There's probably not. It's all got to be pretty random, doesn't it, as far as stumbling onto one?
Well, let's first talk about the best place to look for meteorites. Best place to look for meteorites is where they've been found before. So identify strewn fields of known meteorite falls. For example, Colorado's got a few known strewn fields, but they're oftentimes on private property, so farms and ranches and stuff. So you need to get permission to hunt for them. The Holbrook meteorite strewn field in Holbrook, Arizona, that's where a lot of beginners look for their first meteorite. They typically go there in the spring. There was a meteorite airburst that happened in 1912 or thereabouts. a big explosion in the air, and these pieces peppered rooftops, and thousands of fragments fell to the ground, and people picked them up. And but even though that's been more than a century since that happened, people still go down there and find them. They typically are small fragments now, but I know Dan Ray's found a Holbrook meteorite down there. I've not been down there looking for them. I know other people who've gone down there and looked, never found anything. And but a known strewn field is the best place. The next best place is deserts. So you want to get into the dry lake beds in California, Nevada, Utah, and look for them there, because they tend to stick out a bit more obviously. Dark object on a light surface, but oftentimes you're going to find a meteor wrong. Now the reality is, and this is where it gets into the random part, what's called a cold find, that is just randomly finding one out in the middle of nowhere, does happen. I know of a couple people who found them like that, but the odds are almost zero of making a cold find. So you need a lot of patience. I know one person who is a well-known meteorite collector who took 20 years of hunting before he found his first one. I know of others who found their first one in an hour, but they found it at a place like Holbrook, a known strewn field. So my suggestion is go where they've been found before.
Or go to a store, a rock store.
Or do what I do. I don't have the patience. It'd be fun to go out and find one. I go buy them from the dealers. That way I know what I'm getting.
Well,
Josh,
I think I knew the answer before I asked it, but it's been fun to look. I've
Just looking is a hoot.
been out kicking around the desert looking and picking things up and putting them in my pocket and thinking, all right, this is it. I found what I've got, what I'm looking for, because that's my trophy, is actually finding one on the ground at random.
Yeah.
it may take 20 years, Mark.
And may the force be with you.
Thank you.
Okay, Josh,
Yeah, I was asking, so you mentioned that fragments from Mars and the moon sometimes land on Earth as meteorites.
Yeah.
Does that ever happen with other bodies, like say Venus or Mercury?
There's one meteorite that I recall that is thought by some to perhaps be from Mercury, but the jury is still out on it. Nothing confirmed on any other bodies, although I seem to recall reading recently that there is a meteorite found somewhere that they think might be originally from Earth, that got blasted into space by an asteroid impact and part of the crust, and then came back as a meteorite. I don't recall which one it is, and I think there's still some study being done on that, but no, nothing else from any other body that's known yet.
All right, thank you.
okay, Don? Don?
Yes. A friend of mine is an avid meteorite collector, and he bought at a meteorite or rock show. He has a pile of meteorites, but one in particular, the information that came with it said that it had struck a tree as it fell and lodged in the tree, and was found by somebody going through the strew field and pulled it out of the tree and sold it. And we had an argument then, when is the point that a meteoroid becomes a meteorite, since this one had never hit the ground yet?
That's one I like to kid about is, well, gee, what about this meteorite that hit Ann Hodges? It didn't hit the ground, it hit her. So would you call it a meteorite? The answer is yeah, it made it to the surface. Most likely the meteorite your friend got is Sokotoline, which is from Siberia. That one fell in 1947 or 49. And pieces of that were recovered from trees. Most of the fragments of Sokotoline have been picked out of the ground, out of craters and stuff.
Okay, are there any other questions? Yes, Mark Bennett.
Yeah, I hope I stepped away for a couple minutes. I hope you didn't answer this in your lecture, but how do you go, what's the best way to go about evaluating something you found and appraising it? I know that the School of Mines Museum has a service where you can pay a fee and have any kind of specimen evaluated. But is that the best way, or how do you?
Well, the first thing to do is confirm whether the specimen is a meteorite. And then determining a value is going to be a bit more difficult depending on what kind it is, how rare it is, and so on. And that's typically done after classification. Mike Jensen from Mike Jensen Meteorites will help with identification of suspect specimens. He works for Dave Bunk up in Arvada at Dave Bunk Minerals. And I'm not sure if it's on their website. It might be, but I know he will take a look at suspect specimens and tell you if it's a meteorite or not. He's been involved in buying and selling of meteorites for decades and knows his stuff. Museum of Nature and Science does specimen identification. I think on Saturdays. They used to do it on Thursdays, and they'd have some of the college students help out with rock and mineral identification. As far as meteorite identification, I'm not sure if they're doing that anymore. They used to have an X-ray fluorescence analyzer, a handheld gun. It's had problems, and the last I heard was still out of service, so I'm not sure that they still have it. And then if it is confirmed to be a meteorite, then you could pay a fee to have it classified, and the classification is going to be necessary in order to determine if it's what kind of value it's got. If it's a really common ordinary chondrite, it's not going to be worth all that much. I mean, not on a per gram basis. If it's an extremely rare type of carbonaceous chondrite, for example, that could have a pretty high price. But anyway, so there you go. So classification would have to be done after you confirm that it's a meteorite. Mike
Gardner, you have another question?
Yeah, if everybody else has asked one, sure. Have there been any meteorites found around the Tunguska site?
No, there have not.
Wow.
No impact crater, no meteorite fragments. Of course, they've got the photographs of the trees that were knocked down. The thinking is that that was an airburst that occurred about 5 miles above the surface. And there were debates about whether it was a chunk of comet or a chunk of asteroid. I think the consensus seems to be leaning toward a chunk of asteroid, but there's still some that argue that it might have been a chunk of comet, and it exploded in an airburst and likely completely vaporized and wiped out the ground below. Thankfully, that didn't happen over a major metropolitan area. Sorry?
This is Mike Gardner's wife, Jinky. How do you tell the difference between a comet chunk and a meteorite chunk?
Well, you won't find a comet chunk on Earth. Comets are can be thought of as dirty snowballs. They've got some rocky material in them, but there's a lot of dust and ice and stuff in a comet. So they're a lot different. Meteorites tend to be rocky or metallic.
Thank you.
You're welcome.
Okay. Any other questions?
Wonderful talk.
Yes. Thank you very much, Ron. I think this was very, very informative and quite a few interesting questions here. It looks like there are quite a few people interested in collecting. So we very much appreciate you taking the time, and especially given your difficulty with your RSV. We very much appreciate you taking the time and giving us the talk.
Oh, my pleasure. This is a fun hobby. Definitely a fun part of astronomy.
Yes. Definitely shows. All right. Thank you very much. I'm going to stop.